Hi, I'm Brian Marcinini with the National Electrical Manufacturers Association, and I'll be moderating this session. NEMA is pleased to be co-hosting this webinar with the Alliance to Save Energy. As you may know, the Alliance leads the Active Efficiency Collaborative, which engages a broad stakeholder group working on optimizing energy use and integrating and establishing energy efficiency strategies with the capabilities of digital connected technologies. And this session is part of the Alliance's Energy Efficiency Global Webinar Series. So this webinar will highlight how connection and interaction of multiple building systems can help to optimize energy use and improve building performance. And we've lined up a number of great speakers to help share best practices and lessons learned from successful projects. Like many webinars, attendees can ask questions using the Q&A portal, and I'll moderate those questions at the end of the presentation. So each of our speakers have approximately 5 or so minutes to present, and we'll have a great opportunity at the end for our Q&A. So next slide, please. So first, just a little bit about the National Electrical Manufacturers Association. If you're not familiar with our organization, we were founded in 1926, so getting close to that 100-year anniversary. We represent approximately 325 national electrical manufacturers and medical imaging organizations and companies. We have a three-pronged approach to help our members, one of which is related to standards development. NEMA has approximately 700 standards in the electro industry space that cover millions of different types of products. The business analytics is another piece of our organization. So we do have a business analytics group that provides industry data, customized research, detailed sector analysis, and economic forecasting and modeling services. And finally, we have an advocacy group that helps to provide policy expertise and helping our members define goals and identify options with respect to what's going on Capitol Hill and other state areas. Next slide, please. So, the National Electrical Manufacturers Association, NEMA, has more than 50 different product sections, and one of those sections is the Connected Building System section, and so I'll be talking just a little bit about that. It's focused on how products and systems are related to work together as a system of systems, and so a building management system is like the mortar between the bricks of related systems and products and services, and these bricks are, like fire and life safety systems, HVAC, lighting, elevator systems, power systems, and all kind of, work together in order to, help to improve building performance and user experience. So the NEMA's Connected Building Systems section has a mission and vision, and it's really to, help engage in the education and standardization on topics related to systems of building control. And so this includes characteristics and requirements for hardware and software attributes, and developing system interface standards and protocols, and helping to develop information that's critical for full, building system performance. And so we're helping to facilitate the adoption of the next generation of IT communication protocols for building automation and a number of other activities. A couple of our goals include kind of two key things, one of which is really in the thought leadership space and education and outreach. This helps to define topics related to systems of building control and automation, and also help to target, various education and outreach activities. This webinar being an example of one of those. We also try to help bridge opportunities between different siloed construction division specifications One of our speakers, Wayne Stoppelmore, will talk a little bit more of that in a minute. We also have kind of another key goal, which is on development of guidelines and standards. And so NEMA, as a standards development organization, plans to help develop specification guidelines, standards for integration of various devices and systems, such as smart devices, lighting, into building management system and a connected building. And so we are developing guidelines and standards for integration of mechanical and electrical systems. And so there's a handful of kind of key activities that the section is working on. And so I thought I'd just kind of talk a little bit about some of those goals before getting into the speakers. And so I've covered just some of the high level attributes of the NEMA section. And so what our speakers are going to do is talk a little bit about some of their experiences in the connected building space. So for our agenda for today, again, I'm pleased we have a great lineup of experts, starting with Clay Nessler from Johnson Controls, followed by John Bools from Signify talking about connected lighting, and then Wayne Stoppelmore, as I mentioned, to talk a little bit about some of the specifying building management systems and data integrated buildings. This is something that we've developed some documents on, and Wayne will talk a little bit about that. And then finally, to kind of bring it all together, we have Joe Amador to talk about third-party integration. So without further ado, what I'm going to do is turn it over to Clay Nessler from JCI to talk about a GSA study on data integrated building systems.
Great, thanks, Brian. And as the interim president of the Alliance to Save Energy, I'd like to thank you and NEMA for co-hosting this webinar today. We've been talking about opportunities to expand the knowledge and accelerate adoption of connected building systems approaches. And I think this is a great effort in that respect. What I'm going to do today is I'm going to share some results that were prepared as part of the GSA, the Government Service Administration, the largest landowner or landlord in the world, if you will, their Green Building Advisory Committee. This is a group that works throughout the year. It's an appointed position to be on the advisory committee, and they work on various tasks, some technology related, some process related, involving the design, the operations, and maintenance of facilities. About a year ago, we completed a half-year working group focused on what we call data integrated building systems. And I'd like to share some highlights of that study and some of the key findings as a little background for the webinar today. Next slide. Thanks. So most of these things start with a problem statement or an opportunity. The problem statement in this case is that buildings generally underperform to their potential. We find that time and time again when we have to recommission or retro-commission buildings, and some buildings actually never meet their design intent. And sometimes it's the building systems that contribute to that. More and more data is available from building systems and devices. You can literally Velcro a sensor on a wall now and wirelessly collect the data, but what do you do with it? Building systems aren't interoperable. That's been a goal from a long time, ever since ASHRAE created the BACnet committee. I remember being in an elevator in 1985 in Kansas City at the Muehlebach Hotel, talking about why don't all these systems talk together? And from them, interoperability, much less interchangeability, has been an industry goal, but one that is challenging. And finally, most integrated buildings today are literally one-offs and quite expensive to deliver. The promise would be to leverage best practices and some emerging standards to deliver plug-and-play data integration to improve the performance of buildings. So we developed the term DIBS, which we don't believe anyone has ever used before. but it really defines systems that improve building performance, provide advanced sensing, monitoring, and controls through the automated exchange of data. As my mother always told me, smart is as smart does. Just connecting everything to an IP network in a building doesn't necessarily make a building smart, it just makes it connected. And the real goal here is to improve building performance for occupants and the environment. Next slide. So some key areas. What's driving this? Energy and resource efficiency. Connected building systems are a great way to be able to wring more energy out of a building by detecting faults, by supporting retro-commissioning and ongoing optimization. Again, this is about a year ago, so before COVID-19, but health, comfort, and productivity can enhance through the integration of building systems. And we're seeing examples and benefits of that today. And finally, facility optimization. Data collected by these systems help lay out facilities, optimize workflow, and encourage collaboration through occupancy sensing and tracking. Next slide. So what we found is in talking about this, it's easy for a bunch of folks like us on the panel today to dig into the bits and bytes and ones and zeros and things such as that. But I'd like to start with kind of a use case, telling a story, a real life story of what a smart connected building actually works like. In most buildings, fire life safety systems are standalone. Building management systems, probably connected to HVAC, but probably not plug load control or lighting systems. And it's rare that building management systems would communicate directly with a building or a meeting scheduling system in an office building, but what if they did? Next slide. So here's a use case. A meeting organizer, probably the previous day, looks for a conference room, schedules it, and types in what amenities they want to be there when the people arrive. The building management system is waiting for that scheduled time based on the organizer's schedule and returns from setback, making the room comfortable 15 minutes before the meeting starts. Well, that saves energy because we're not just starting it up at 7 in the morning based on a fixed schedule. 15 minutes before the start time, the lighting adjusts up a little bit, the blinds open a little bit, as long as there isn't a direct glare in the room, allowing a meeting organizer to prepare for the meeting with PowerPoint and slides and donuts. The light level increases when the room occupancy sensor detects people entering the room, and the plug load control system turns on the projector and other display and computing devices in the room. At starting time, the ventilation is adjusted to exactly match how many people are scheduled for the meeting. If more people show up, it can increase ventilation based on the CO2 level. And if it's one of my staff meetings and no one shows up, then we can save energy by reducing the ventilation into the conference room. If there's a fire life safety event, the lighting control can capture that and automatically start flashing lights and adjusting lights to provide for safe egress out of the building. When the room's unoccupied for more than 15 minutes, we close the blinds, temperature controls set back, ventilation controls go to minimize, and the plug loads turn off. Think of how much energy that could be saving right now in conference rooms all over the world, which are essentially unoccupied but still using lots of energy. Next slide. So what does that add up to? ACEEE has an initiative for about a decade called Intelligent Efficiency, which looks at the smart functionality of systems in their own right and when connected together. And a combination of plug load, window shading, HVAC, and lighting controls can deliver somewhere between 8 and 18% additional energy savings through these integrated systems. Now that's a significant amount of energy enabled through connected building systems. Next slide. So how do we do it? How many of you on the webinar today have a smart home device? I do. I can talk to my thermostat, I can turn on lights, I can do lots of things from my iPhone. Now, Why is that easy to do? Relatively. I go to Home Depot or I go to Lowe's and I buy a hub and I buy some connected devices that conform to one hub standard or another. I connect them together, and after some mind-numbing app configuration, I've got a smart home. So why doesn't that work in commercial buildings? Well, because commercial buildings are a little bit more complicated. Next slide. So in commercial buildings, there's a number of ways of doing integration. One common way is what's called middleware. Middleware is a chunk of software running in a server someplace, maybe in the cloud, maybe on premise, which basically implements a whole bunch of different communication protocols for lighting, elevators, HVAC, you name it, okay? So imagine, you know, a legion of programmers continuously updating software to be compatible with the latest version of all these devices. And then middleware, it talks to a variety of different third-party applications. Well, these apps change over time and they all have different interfaces as well. That is a way to deliver an integrated building, but it's pretty labor intensive, it's specialized, and it's expensive. Next slide. So how would you do it without middleware per se? One, it'd be great if these devices used a common protocol, such as BACnet, such as LAN, such as EIB, such as various Zigbee wireless protocols. And it'd be great if we had common metadata or schema, if we had defined a structure by which the data could talk to other pieces of data within the facility or the enterprise. And it'd sure be nice if we had some common application services like reads and writes and common things. That would allow you to more easily maintain the connectivity, but it still isn't what we would call complete interoperability. Next slide. So in the interest of plug and play, which is a term that's used way too lightly. The current industry situation is more like plug and pray. I get devices, I wire them together, I power them up, and I hope they communicate with each other and talk some meaningful way. There's a number of standards initiatives underway. Haystack, which defines the tagging, the name of different data from different systems, so that it's much easier to suck that data up and be able to do analytics on it and present the data. Think of a commercial building and something called a space temperature sensor. One vendor or system calls it space temperature. Someone else calls it room temperature. Someone else calls it zone temperature. Someone else calls it T-stat. These are all different names for the same thing. If we could all agree on naming, it would be easier to pull the data together. There's something called BRIC, which takes it beyond the name of data, but it puts it in the context of an overall building so that I can pull things together and perhaps use BIM models of what the building is and the spaces and the zones and be able to use that information to help do this. These are long-term efforts that really offer the opportunity of literally being able to plug things together and quickly be able to deliver value. Next slide. So, little market research. For 13 years, Johnson Controls has been administering the energy efficiency indicator. Last year, 10 countries, 1,400 commercial, institutional, industrial customers around the world. And this data is compelling, actually. When asked whether they had implemented any systems integration, this is the percentage of organizations that had integrated security systems with other systems, fire life safety with other systems. 70%, that's a high number. Now, think about it. Fire life safety, probably integrating a fire alarm with a smoke purge sequence in an air handling unit, flashing lights to show egress, maybe pressuring the floor above and below. That's the type of functionality that you can implement when you provide the system-to-system integration, lighting, building management, all the way to integration of buildings with the grid. My last slide. So we came up with 4 key challenges for adopting and accelerating the implementation of data integrated building systems in the federal government. One was lack of training and education, lack of interoperability standards that we've talked about, lack of system specification and procurement guidelines, and finally, a lack of the life cycle cost and impact data that can really inform the business case for providing this. All of those challenges are also opportunities. If you get rid of the lack of, the real opportunities here are to increase training education, increase work on standards, increase specification, which actually you're going to hear about from Wayne a little bit, and then finally collecting data on the performance. So turning these challenges to opportunities is really the opportunity in front of us. Thanks a lot for this, and I look forward to hearing the other participants. Brian, back to you.
Great, thank you, Clay. Now I'll introduce John Bools from Signify to talk about connected lighting.
Yeah, thanks, Brian. Thanks, Clay. This was a great introduction. Just next slide, please, and we'll jump right into it. Great. So instead of kind of taking you through a little bit of a deep dive into the connected lighting, which we kind of will touch on, but just kind of getting you an understanding of where we really looked at lighting within the smart building and really identified where the best use of smart connected lighting would be. So if you really look at the majority of the challenges that is right now in the existing commercial space and even industrial space, it really comes into the three buckets that I think Clay touched on pretty easily, which was energy efficiency, which is obviously saving energy that everybody's looking at. But the other two pieces that are really important is the space utilization and the productivity of the workspace. And hopefully by the end of the few minutes that I have with you here, you'll understand that the lighting piece of the puzzle or the integrated system does a lot more than just saving, a few dollars on the energy bill, but it really does go farther out. I think we have a use case for you at the end of the presentation that will actually highlight that for you. That is actually 1 to 10 almost. So 10 times the savings really comes from space utilization and more productivity. But if you really think about it, about 20% of energy is consumed by lighting, 50% of average office space is utilized. So that leaves half of the building, typically on average, not utilized. About $10,000 of average cost per desk per year. That's the cost that organizations and firms pay. About 33% of all meetings are unplanned or either quickly or last minute spaced. And 20% of meeting rooms booked are not necessarily utilized. So people book them and forget them. Well, now, when you look at all this, there's a lot of monetary figures that will really play into this. So next slide. So if you really look at those similar buckets, energy consumption, space utilization, and worker productivity, you really start to see the value of how a smart system, and especially a smart lighting system, will play a long role there. Lighting going on and the forgotten to turn off, they're not controlled properly, either they're not grouped properly if there is a control system in place. They don't dim the way that they're supposed to or that they're designed to, or even they're utilizing older technology that is not really making big use of the existing energy saving technology like LED, for example. So if you look at this, that is very easy to look at in terms of the absolute dollar figure. But where would the lighting system really go and make a dollar figure there is really when you connect all those three spaces. So you connect the luminaires to the space and ultimately connect the spaces and the luminaires to the people. And quickly you'll start noticing that there's a humongous amount of savings, but also humongous amount of value that comes in from well-being or talent retention, or even from that matter, how that lighting system really plugs in and works with the remainder of the building management system. So for next slide. So how does all that fit within the lighting control system or a smart lighting system? If you do have a lighting system in place that is commissioned properly and utilized properly, you're able to quickly pinpoint down to the individual component or the light fixture. A lot of light fixtures now come with integrated sensors that are capable of a lot more than just scheduling the light or dimming them down, or even daylight harvesting that we've all been talking about for a long time. But those sensors now are multi-sensors that are, doing a lot more than that. Things like occupancy, things like heat mapping, or capturing temperature or humidity rating, things like even noise detection. Uh, a lot of them have VLC technology where they can pinpoint position within the space. If you actually put all this together, whether it's occupant density or even the flow of the users in the space, you put that into all system analytics, you really come out with a great solution, because not only that you have real-time space allocation of all entry points within the space, but you also have things like you can actually make decision based on. So data that can be visualized to, for example, be fed back to the user, like wayfinding. So it's actually, from current projects that we've done, wayfinding is one of the biggest ones, especially in different retail applications, or even hospitality applications. Sorry. So there's a lot of that, and when you really think about it, it's like Google for indoors. And then you sum all that up with major reporting on how the space is being used, how it's connected to like your HVAC system or your other building management systems that are existing in the place or even offered by others. It just looks at it and it all makes sense. And the energy consumption really multiplies. So the energy savings really multiplies when you start integrating all those systems together, along with the lighting data that is being collected. So next slide. So if you really look quickly at an architecture example of the lighting, smart lighting system, it goes without say that you have an illuminated space, that the actual where the space is, where the majority of the apps are being used to kind of almost a feedback into the system. But you have a digital canopy where all happens, right? So there your lighting, your HVAC, access points, all the other occupancy and light and heat, humidity, and motion gets kind of put into that category. And then you have a network infrastructure that basically have those components that brings all that together, or get those components to talk to each other. And then on top layer is the management and the monitoring analytics that allows you to visualize all this data to make sense out of it, and based on it, you make the right decisions. Next. So I like to call this the smart triangle, because it really is. I mean, when you're looking at data-driven, lighting or technology in general within the lighting fixture, you're really looking at what people really want and need, right? So it has a little bit of a historical view, but it also have a very futuristic view. So if you think about this, you have a sensor that senses what's happening in the space, responds to it from either a location specific or information, or even a service that's being responded to. And then you have an anticipation, almost an artificial intelligence piece of it that actually tells you what things you can do in the future to basically react to those, or even proact to those exact senses that you've been gathering. So this is actually where a smart system or a smart lighting system would be complete. Next slide. I'm going to talk about the probably one of the best and most talked about use cases, the edge building. This is a 300,000 square foot building that featured about 6,500 enabled smart luminaires. Not every luminaire got a brain on its own, being a sensor that is, but there's about 2,000 smart connected portals that are in the shape of a smartphone, or users, we call them, that are being tapped into this project. So if you actually think about it, the next slide is going to demonstrate for you not the energy savings, But one aspect of the three buckets, if you remember, that we started with, so there was energy consumption, there was space utilization, and then there's productivity. So this takes into account just a space utilization example on how to put that into a monetary savings perspective. So this is a real life example that we've worked with Deloitte building. They started off with a Crystal Tower building that they already had existed. This place was about 245,000 square feet. They had about 1,600 employees. And if you actually, and there's about the way that you look at it is always $1 per square foot. So based on $1 per square foot, there was $29 per square foot on average that they have determined that this is the value of the real estate. If you actually look at the square foot per person or per employee, it's about 153. If you actually do the math quickly, cost per employee, you're looking at about $4,473 per employee that they have to pay, or that this is basically part of their expenses. They were coming up with a brand new building called The Edge in 2014, and they asked to do some analytics to understand what they're trying to do and how that's going to impact their financials. So the building was a little bit smaller than the original Crystal Tower baseline building that they were basing everything on. It was 220,000 square feet, but their employees has grown by about 9%, about 1,740 employees. Now, if you do the math, it's smaller square footage, more employees. So the average dollar per square foot is about $40. So it jumped up. Now, with all that, taking the exact base building and then adding, the employees on top of a smaller building, you could see that the cost per employee start jumping up pretty easily. So if they had done nothing on that building without any control smart system, they would have actually lost 1.1 million. So that's an extra expense that they would have had to pay, if they compared the Edge to the Crystal Tower original building. Put a smart system in, put the analytics, and we were able to actually put in a lot more employees in the exact same square footage being 220,000 square feet. Obviously, the average dollar per square foot stayed the same because the square footage didn't really change. But look at the square foot per employee. It dropped dramatically. If you actually take a look at the cost now per employee on that real estate, it's actually 31% less, a little bit even more than 31% less. So they're able to actually save $4.1 million a year just based on space utilization. To put all those numbers together, we're looking at a smart system that has 40% lower cost per employee, per full-time employee. It has 35% less space, being 245 down to 220. And then 34% more full-time employees. So that's being 2,900 employees that now can fit into the same space versus the 1,740 that they've started off with, with their base. So if you actually look at this, this is the analytics and how you can actually take that and link automatically to a dollar figure and savings. And that's not even including all the energy that we'd be using a smart system or smart lighting system. And on top of that, even the employees in terms of productivity that they would have. I mean, the smart system comes with a lot more applications that actually does work on the well-being and the retention of those employees that they're just adding to that same space. So again, saving a lot on all different levels. I think this was it for me, and I'll hand it right back over to Brian, and we'll take questions later on.
Great. Thanks, John. And as you have questions, feel free to put them into the Q&A box at the bottom of the toolbar. But next we have Wayne Stoppelmoor from Schneider Electric to talk about specifying building management systems and data integrated building systems.
All right, thank you. Thank you, Brian. Thank you, everybody, for attending. An intelligent building includes many connected systems, as you've previously heard from Clay and John, that the smart buildings are made up of several systems to make the building operate. And this slide you see, you got your HVAC rooftop unit on the top of the building, you have some solar panels, you got some EV equipment, electric charging for cars in the lower level, and all the buildings with occupancy sensors are throughout the whole building, and everything needs to be tied together. So if we go to the next slide, traditionally we've had the HVAC controls for the BMS and all these systems kind of tied together. However, as we go forward into the future, how are we going to control things? We need to be thinking about that. As a building operating system, does a traditional BMS do it? So we got these things like the fire alarm, we got the power management system, the lighting controls, we got blind controls, as we mentioned before, access control when you get into security, you got smart grid, we got demand response coming online when we start thinking about decarbonization of the planet. So we got all kinds of tools that we want to use to lower the efficiency, or even if it's not efficiency, as much as the carbon needs. So if we go to the next slide, we have various perceptions perceived on how a building looks like and what's supposed to happen. We have how the customer explains it. This is what looks at how the project leader understood it, then how the architect designed it, how the programmer wrote it, and see, everything's different. How the consultant described it, how the project was documented, what the contractors actually installed, how the customer was billed, how the project was supported, and finally, this is what the customer actually needed. So we need a system to put in place. How do we go from this point of what the customer actually wanted, how he reflects it to who he specifies it to, how we move on and make sure a building ends up the way the customer actually wants it. So if we go to the next slide, we'll see that there is a system in place as a standard called CSI Master Format, which is a standard for specifying building constructions. It's used in North America primarily, and it's basically an indexing system. It's a standard that shows you on pointers to organize your specification. It's similar to, say, the Dewey Decimal System. And this system, the standard, is made up of several construction divisions, and the divisions are based off the basic trades. You have plumbing in Division 22, your HVAC systems are in Division 23, electrical and lighting is in Division 26, and it goes on and on. So it's broken down into various various trade construction type of divisions. So it's all laid out, and the specifiers put their specific areas into those divisions. But there's a problem with the traditional use of master format, and it's the fact that they're nicely packed in different divisions. However, those divisions become very siloed, and these silos impede connected building systems design. So what are some of the problems with these silos? Well, when you get into the installation and the designing of the specific things, so HVAC and the mechanical people are putting their specifications in Division 23, where the electrical designers and specifiers are in Division 26 and the installers in 26, and they may not even be in the same office. They may not even be in the same part of town or even the same building. And so there's no communication between the two divisions and to the two installers and contractors. The second one is the building management systems have traditionally been placed in Division 23 with the mechanical engineering piece of it, the HVAC systems. When you place that, and with the problem with that, when you place in Division 23, the other trades don't typically see it. They're not looking in the other divisions and the other specifications, so they don't know what's going on with the BMS. And finally, not finally, I'm sure there's others, but this highlighted here is, so specifiers themselves typically only are interested in their specific area. So the mechanical engineers is only looking at 23, like we spoke of. And when they design the spec, they may not be the experts in the BMS. They may not know, because it's an integrated systems and we're tying in all the pieces. They may think they're going to hand it off to a building integrator, or they're going to bring in a company like Johnson Controls or Schneider Electric to write the BMS and tie everything together. So you may see something in the spec that reads something similar to building integrator shall provide integration of the XYZ control system with the building management system. Well, how do you do that? There's tons of questions. How does that happen? What are the cables you use? You use a Cat5, you use twisted pair. Do you have a protocol? Clay mentioned, do you use BACnet? There's all kinds of questions, other things of what integrator to use, who gets paid, what happens if you want a time clock. So just many things that happen. So there's a solution to this, and our recommendation, and as Clay mentioned and Brian talked about, is that we really like the use of Division 25. It's new. It's relatively new, and it looks, I mean, it's not that new, but it was put in place in 2004. And it was a placeholder. It's the integrated automation, and it's Division 25. It's the intent of putting all the integrated piece, make everything interoperable from one division to another. It's a central place to put your specifications that tie all these separate pieces, all the connected systems and devices into one spot, one specification in the building. So with this, with doing Division 25, it's okay to point. Your mother always said, don't point. Well, in this specific case, you do want to point. You put your actual spec, and let's say you want to use BACnet. You put it in Division 25 as a spec item, describe it there, and now you can point from Division 23 in your HVAC system. We're going to use a protocol. We're going to use BACnet. So you refer back to Division 25. Same thing in the lighting. Say you want to use BACnet for your lighting control systems. You put that in Division 26, and you point, or you point back to Division 25 what the actual specification that you're going to use BACnet. Also, recommending you want to put in a sequence of operation, and the sequence of operation tells you what each system does, because a BMS can't control anything it doesn't have permission to. So you start, and through this whole process, and you get all the separate building systems talking to each other. So you bring the design, the specification of the building up front from day one, rather than bring it in at the end of all your systems, to where you've pulled your wire. Say the mechanical people have pulled some wire, you got your electrical people pulling wire, then what do you do for wiring if you're going to go a wired system from a BMS? So everything's pulled forward. So let's go to the next slide. And then in the use case that Clay provided, he had an aux sensor for the conference room. You have people coming in, you're adjusting the temperature, you're bringing in the light levels. Now it's all shared data. You take that data, instead of using multiple occupancy sensors for doing the same function, you use one occupancy sensor, and you share that data across the different divisions. So if you're having your lighting control in Division 26, now if you're using it from an HVAC control in Division 23, you just use that one sensor, and everything just flows very nicely. All right, and then so what are the benefits from using Division 25? Well, it makes the whole building interoperable. All the connected systems are interoperable from one to the other. Everything's laid out nicely. Everybody knows what's going to happen, and the building then gets designed and specified and built correctly to what the owner actually wants, and how the building will operate will make that building energy efficient. It'll make it sustainable. It'll make the wellness, the air quality of the building better for the occupants. You also, as you're running the lighting and your heating and cooling systems, it's going to make the operation of the building cheaper for the operators, or for the renters if people are renting that facility. And it makes a workspace more efficient. There's a more occupant friendly, let's say, from a lighting perspective. The temperature is even, and it's the way it wanted. You don't have to have space heaters. And there's many other benefits. So with that, then if you need more information on the subject, NEMA has a white paper. It's out on NEMA's website. There, I believe this presentation will be sent out, so you can just click on the link and you'll be able to read it in detail and get more information.
Great, thank you, Wayne.
All right, thanks, Brian.
So last but certainly not least, Joe Amador from Amador Consulting will help to bring things home with a third-party integration presentation.
Yeah, thank you, Brian, and thank you all. I'll be fairly quick because I know we wanted to spend some time getting questions from the audience, discussing. So what I wanted to just talk about very briefly is as Brian said, wrapping it up, there are a couple points that were already made. Why do we need third-party integration? What I like about this graphic on the right, which is from the Building Performance Institute in Europe, is that it does kind of explain the fact that there's a wide array of needs when it comes to integration or benefits, if you will, right? From the energy side of things, a more efficient grid, a more reliable and distributed grid, and then also the occupants' health and safety, which is certainly something that is coming into mind more so now in the age of a pandemic. So there's the challenges in why it's difficult, and there's a lot of legitimate reasons why it's difficult to integrate these systems. There's a lot of huge benefits there that stand to give us value, give us more out of our buildings. We can skip to the next slide or move to the next slide. And here, what I was hoping to touch on more specifically is systems integration. And systems integration is certainly a thing, right? You're trying to integrate systems together, but it's also a service. You're seeing a lot of acceleration around firms that offer what's called master systems integration services, or an MSI. I'm an MSI, I'm a master systems integrator. And typically what that means is, rather than integrating your control system to control HVAC, or your lighting system, which controls lights, and more than lights, as John made the point, you have an integrator that can actually bring them all together. So on one hand, that has been talked about as the missing link, but at the same time, there are products, services, protocols, initiatives like Brick and Haystack that are really focused on maybe not doing this as a service, but making it more of an automated process. These systems will automatically connect. This graphic on the bottom left, or on the left side, is from Boston Consulting Group. And what's interesting to me, a lot of the main consulting firms like Boston Consulting Group, McKinsey, are doing a fair bit of work around smart buildings, but they all tend to note the importance of connectivity, the importance of systems integration. So this graphic, just without describing it in great detail, the point is, across multiple types of systems, there's a lot of opportunity, both in growth in that market and size in that market, around systems integration. It's an observed fact across the industry. We need to spend more money, and there will be more money spent integrating these systems together. So you're seeing new vendors that have solutions to do this. You're seeing new protocols and standards like Brick and Haystack. You're also just seeing new use cases within specific integration, and also the benefits of the integration, which is what was on the last slide. And then we can go to that next slide, just wrapping things up. I also want to share just some of the research out there on the market opportunity here. And there's on the left side a slide from Memori, which is a few years old, admittedly, but it just talks about the growth in connected devices. So on one hand, that both creates maybe a bigger problem. More connected devices that aren't connected to each other creates a bigger mess to integrate. And at the same time, it also creates more need and demand to integrate these systems. And that's the second piece, is what I see happening. We'll have more systems that can connect to the cloud, that have an API, and that raises awareness and creates demand for integration. On the right side, this is actually from McKinsey, and they wrote a pretty interesting white paper maybe a year and a half ago, and really focused on the future of building controls and building automation, and noted that much of the growth over the next 5 or so years will be in connected building systems, as opposed to what they referred to as traditional systems. That's the gray, where it's still the biggest slice, the biggest piece. Big buildings will continue to have building automation systems, lighting control systems, access control systems. They don't necessarily project a lot of growth there. Most of the growth they project is connecting these formerly, as they say, formerly discrete building domains, and that will become, not close, but a significant share of total building automation system. So there is a fair bit of projection or data out there and research out there indicating that this is just a growing market. We're in the coming years going to see a lot more spend, which will lead to more innovation, more companies entering the market offering solutions. I think that was quick, but I'll keep it there. And feel free to connect with me if this is a topic you want to discuss more.
Great, thank you, Joe. What I'd like to do is get into some of the Q&A. There's a question that's come in through the Q&A session. Clay, this one's for you. What are the top top steps that you think Congress should take to advance integrated buildings, and how do we do a better job of educating new staff that come into Congress on the role that digital can play in Build Back Better and upgrading our infrastructure?
Yeah, great question. There's actually some legislation that's been proposed, and it's called the Smart Building Accelerator. It's modeled after the various Better Building accelerators that have been very successful through the Better Buildings program and the Better Plants Challenge. So the accelerator would essentially direct, as policy and legislation does, the Department of Energy and the GSA to enter into programs of demonstrating technology, of benchmarking smart buildings in the commercial sector, not just in the government sector, but in the private sector as well. And so essentially increasing the knowledge base, coming up with best practices, documenting that. Many of the challenges that we addressed in the GSA DIBS task force, which of course doesn't create policy, doesn't create guidelines, it's merely an advisory group to the GSA, would be addressed through that. I would also point to some very interesting legislation in Europe called the Smart Readiness Indicator, which is being bundled with the renovation wave as a way of increasing the renovation of existing buildings. Their goal is 3% renovation rate, whereas now it's slightly below 1%. And the Smart Readiness Indicator is a really neat kind of metric, sort of like a building efficiency standard, like EPA's Energy Star Portfolio Manager, providing a score of how prepared a building is or ready for the integration of EV, solar, PV, integration with the grid, addressing health and wellness, and electrification. It's a very broad and I think extremely well done thing. And member states will have the option of incorporating that into their drivers. So those would be two really good models that could drive the adoption and investment in smart buildings.
Okay, great. Thanks, Clay. Joe, I have a question for you. What are some of the biggest barriers that have created headwinds for smart building technology adoption?
Yeah, there's a number of them. I think one, the traditional upgrade cycle of a lot of the control systems in buildings is 10 plus years. So in many cases, if you're budgeting from a capital planning point of view, the upgrades of your buildings, you're not looking at upgrading a lot of the controllers, a lot of the software in that building. So that creates just an unplanned maybe or unscheduled set of upgrades to maybe deploy a smart building solution. I would also say, and Clay touched on this a little bit, a lot of the data in the buildings, it may be unclear to a lot of people who are in the buildings, not those running it, but those that are spending money on the building, that getting the data out is actually very, very difficult. And I've seen small vendors, I've worked for small vendors, that it can take weeks or months. And sometimes the work itself may be measured in hours, but the timeline can be measured in weeks or months because there's data that isn't easy to get. You don't have a full documented list of all your points in your building. And because of that, it takes a lot of time to figure that out. I would say in the past couple of years, there's better data solutions out there, technology solutions to address this. I would also say that the ROI is there, but the ROI may be hard to detect on the front end. And what I mean by that is you're spending money up front to deploy a smart building solution. Usually those products have an upfront cost for implementation and for hardware if you need hardware, and then they have an ongoing license fee. And you can look at that and you can compare that to your energy savings. And there's good research, there's really good research that even data about your building will drive some savings. I would say we can go beyond that and drive drive people to make changes in their building. There's a variety of ways to do that, and that will drive even more savings. But there's still, to some degree, not across all building operators, but and owners and operators, but there's some sense that I'm definitely spending this money up front. I'm definitely deploying this hardware, and I think I will save that energy. But if I save some of that energy and not all of that energy, the ROI is not as attractive. So from a risk aversion point of view, there's still a little bit of risk around definitely spending money up front. I'm definitely spending money on a license fee basis. I think I'll save energy. I'm confident. I'm not sure I'll save quite that much energy. And you can also point to research where there's an average savings, but there's reports from the federal government, from others, where some buildings saved very little, some buildings saved a lot. If you have a portfolio, you can certainly de-risk it, because across your portfolio, you probably have some poorly managed buildings and some very well managed buildings. You'll still get a good, compelling savings. But if it's one building, it's maybe 5 years old, there may be some concern within that building. You might not see a huge amount of savings. So those are some of the risks. There's plenty of others. I think those are some of the key ones.
Great, thank you. Wayne, a question for you. What should an architect do to assure that a building is being built in accordance to the building owner's needs?
I think the biggest thing they should do is utilize Division 25. And I think they need to bring all the trades and all the designers and the spec writers up front. They need to get it started from day one so they can proceed and make the building interoperable. They need to break down those barriers and silos that make it hard to make everybody to talk together.
Okay, great, thanks. John, a question for you in just about a minute or so left here. What are some of the most sought after IoT applications which illustrate what smart lighting systems can do?
Sorry, I was muting myself there, just so I don't interrupt anyone. But sure, yeah, like there are a few. I think one of the, or a couple of the most popular ones are definitely space management, indoor navigation, and definitely energy optimization ones. So things like the apps that will show you different reporting based on the day and the time of usage, how that gets integrated into other like HVAC systems or BMS, or even from that matter, getting APIs pushed out from those reporting to existing other systems. But I'd say probably by far, those are the three that are mostly used.
Okay, thank you. We have a lightning round that I want to get to, but I guess I was just thinking about a question, maybe Clay, if you wanted to take a stab at it. How can connected building systems help to protect building occupancy and occupants during the pandemic that we're facing now?
Clay, you're on mute.
Yep, that's actually a great question, because what we're seeing is the need for buildings to be more flexible. Buildings, most commercial office buildings, let's say, have two modes. They're on or they're off. And they might have a free cooling mode, right? To save a little bit of energy if it's cool outside. What we're seeing now is that the way you operate a building at reduced occupancy with social distancing during the coronavirus is much, much different. We're increasing filtration. We're increasing ventilation rates. We're putting in air treatment. That all uses more energy. And imagine a scenario which is happening right before our eyes. I'm a public building and I've got a wildfire. I'm evacuating a bunch of people from their homes into a high school gymnasium, and a bunch of them could be COVID positive, and PG&E or another utility shuts off the grid. So control systems, I think, are going to have to be increasingly automated and flexible to account for all these various operational modes. And that can really benefit from integration, knowing where people are, knowing how many people are here. The technology used to track and trace people who may be COVID positive can be used to optimize energy and improve the indoor environment. So I see this as being a boon for smart buildings, not a barrier to it.
Great, thanks, Clay. Just in the last minute that we have here, I'd like to do a lightning round with about 10 to 15 seconds for each of our panelists to answer this question. If you could provide just a word of advice, or think of it as a very, very short tweet to accelerate the adoption of smart building systems, what would it be? And we'll do it in the order of the presenters. So Clay, we'll start with you. Think
about the occupants. In that scenario, the conference room scenario, we actually have that in our headquarters. By far the most popular and important feature is the one that detects no one's in the conference room and frees it up so someone else can use it. do not underestimate the value these systems can provide around occupant productivity, convenience, comfort, things like that. COVID aside, think about the occupants, not just about energy and other things.
Thanks. John?
I'd say plan your integration around what you need, not what you can get.
Perfect. Wayne?
Utilize the Vision 25 to not only make the building interoperable, but make the specification systems interoperable.
And finally, Joe?
I'll say, technology and data, it's the journey, not the destination. So keep that in mind. It's probably a play on some of the other things people have said, but that's what I came up with.
Okay, great. Well, I'd like to thank everyone for participating in this webinar. Hopefully it was useful and you learned something. I know that the slides will be made available. And if you have any questions, I'm sure we can put you in touch with our panelists. So thank you, gentlemen, for providing your time this afternoon.
Thank you for having me.
Fine.
All right. Thanks,
Thank you.
Brian.